In this video, we will look at infinite limit and limit at infinity. So first we look at infinite limit. We look at the definition. Given limit of fx when x approach a is equals to infinity if the function of fx approaches infinity for all x approach sufficiently close to x is equals to a from the left and the right hand side without actually letting x is equals to a. So similarly, given that the function of limit of fx when x approach a is equals to negative infinity, if the function of fx approaches negative infinity for all x approach x is equals to a from the left and right hand side without actually letting x is equals to a. So it means that, as we learned before, left hand limit, in order for a limit to exist, left hand limit must be equals to the right hand limit. Let's look at one example. Let's say in this case, case 1, the function and graph of fx 1 over x squared is as shown in below. So this is the graph for 1 over x squared. So you can see that in this case, our x is equals to 0. So limit, let's say, limit when x approach 0 from left hand side for the function of 1 over x squared. So you can refer to this graph. So here is 0, x is equals to 0. This is the vertical line, is x is equals to 0. So as x approach 0 from left hand side, so you can see that on our left hand side, the graph is approach. So this graph is approach x is equals to 0 from the left hand side. As x approach 0 from left hand side, you follow this arrow. So the function is approach positive infinity. So here is positive infinity. Now so let's look at right hand side. So here is the right hand side. So limit when x approach 0 from the right hand side. So the function is 1 over x squared. So as x approach 0 from the right hand side, again you follow this arrow. So the graph will approach positive infinity. So again here is positive infinity. Since left hand side and right hand side is equals to positive infinity, so the limit for this function from left hand side and the limit for this function from the right hand side, both of them are approach positive infinity. So I can say that limit when x approach 0 for the function of 1 over x squared is equals to positive infinity. Now let's consider case number 2. So you can see that in case number 2, this is the graph for the function of 1 over x. So let's look at this case. So you can look at this one. This is approach again. This is approach 0. So limit when x approach 0 from right hand side. So first we look at the right hand side for the function of 1 over x. So as x approach 0 from the right hand side, here is approach positive infinity. Whereas when limit for the function of 1 over x, as x approach 0 from the left hand side. So here is the left hand side. So when x approach 0 from the left hand side, follow this graph, this one will approach negative infinity. So the limit for the left hand side is approach negative infinity. On the same time, the limit for the right hand side is approach positive infinity. Now one is negative infinity, another one is positive infinity. So when limit for x approach 0 for the function of 1 over x. Since one is negative infinity, another one is positive infinity. So the limit when x approach 0 is does not exist. So in order for a limit to exist, left hand limit must be equals to the right hand limit. In case number 2, the limit from the left hand side and the right hand side are not equal. Next, we look at limit at infinity. So limit at infinity means that, so as x approach either positive infinity or x approach negative infinity. So this means that limits at infinity. So limit at infinity means one of the following two limits. So one is limit of fx as x approach positive infinity, or limit of fx as x approach negative infinity. So they are used to describe the behavior of the function fx as the independent variables. X increases or decreases without bound. If x increases without bound, means that here is increase, means that it's approach positive infinity. So it means that x approach positive infinity. If x decrease without bound, means that x approach negative infinity. So if a function approaches a numerical value L in either of this situation, we write as limit for the function of fx approach positive infinity is equals to L, or limit of the function of fx as x approach negative infinity also equals to L. So we can write equals to L if the function approaches a numerical value of L.